This film explores the options for insulating and improving energy efficiency of traditional buildings. Start by looking at the easy ways to save energy in your home, including draft proofing, efficient heating and lighting, and even thicker curtains. As covered in our earlier films, choosing the right kind of material is important when working with traditional buildings. This also applies to insulation that needs to allow the walls to continue to breathe. This may result in different choices from those used for cavity wall buildings, and in some instances, it may not be feasible to improve the performance of some elements of the building fabric. Every building is unique, so this film can only provide general guidance. More ways to get specific advice are available on the Cumbria Action for Sustainability website. Before starting a project, make sure the building is weathertight. Check that the walls have no existing damp issues that need attending to. Fix gutters and downpipes, roofs and leaks. This is covered in our earlier film, Damp and Rain in Traditional Buildings. The biggest contributor to climate change is the emissions from fossil fuel burning for energy. So to keep fossil fuels in the ground, we need to use less energy. As well as reducing carbon emissions from heating, improving energy efficiency will also result in a warmer, drier and healthier home and reduce fuel bills. Many traditionally constructed homes have no insulation in the walls, and many have none in the floors, and some may not even have insulation in the roof. So, in most areas, the efficiency of the building can be upgraded. It is, however, important to remember that by insulating your home, you are changing the way the walls, roof and loft space and floor manage moisture. If you use the wrong materials or don't have the work done properly, then moisture issues can arise, leading to increased deterioration of the building fabric. Even with the right materials, there is a risk of condensation, so always seek experienced professional advice from a conservation architect, surveyor, or conservation contractor before commencing a project. A wall can be insulated on the external face or the internal face. External wall insulation has the advantage that there is no loss of internal space, and it keeps the wall warm using the mass of the wall as a heat store. It will, though, require major works that will change the external appearance of the building at the roof line and around the windows and the doors, for which consent may be needed. Internal wall insulation doesn't change the external appearance of the building, but has the disadvantage that the works can cause significant internal disruption and result in the loss of internal space and can impact on original internal features and will mean the movement of surfaces. The original wall will also become colder. It is also important to recognize that moisture evaporation from the wall is dependent on the wall being warm. Whilst this will vary from wall to wall, you need to consider the impact of reducing the wall temperature when insulating internally. Over-insulation may inadvertently compromise the ability of the wall to dry out properly. This doesn't mean that internal insulation is harmful, just that the level of insulation needs to be considered. Suitable insulations are those that are described as being vapor permeable. For external insulation, solutions include wood fibre, cork or hemp fibre boards that can be rendered in lime, as well as lime-based renders with insulation materials mixed in. These are then finished with a breathable paint or lime wash. For internal insulation, again, wood fibre, cork and hemp fibre boards are an option, as well as a number of lime-based plasters with insulation materials mixed in. These can be more sympathetic to uneven wall surfaces in some older buildings. A suitably breathable paint finish is also important. Insulating plasterboard or foil-back plasterboard are not compatible with breathable solid wall construction. Building a new inner stud wall with rigid board insulation or insulating plasterboard will also restrict the breathability and may increase the risk of damp and condensation issues behind. Whether you are able to insulate the floor will depend on if it is a solid floor or a suspended timber floor. Many old buildings have porous flagged floors laid on earth or sand, staying dry by allowing the ground moisture to evaporate away. Any insulation introduced as part of a new floor will therefore need to be compatible, as there is a risk that the moisture will be redistributed elsewhere. This often happens when insulated concrete floors are introduced. Breathable solid floor options include limecrete and hempcrete. You will though need to consider if there is sufficient depth to the foundations, and you will also need to consult your local planning authority, as permission to lift the existing floor may be required. It's best to seek expert advice. If the floor is a suspended timber floor, then there are more options for adding insulation under the floor, particularly if the boards can be lifted or access is possible from below. Options include sheep's wool, hemp fibre, cellulose fibre, which is derived from recycled newsprint, and wood fibreboard. These types of breathable insulation allow both air and moisture vapour to pass through slowly, minimising the risk of condensation. The insulation should be cut carefully to fit tightly and fully the space between the joists, as any breaks will allow air movement and heat loss and will encourage localised condensation. Roof and loft insulation can be introduced between, over or under rafters, or between and over ceiling joists, and there are a range of options available. By introducing insulation, you are changing the environment within the roof space, and it's important that they are well fitted for the same reasons as floor insulation. Insulation at ceiling level will cool down the loft, so maintaining eaves ventilation is important to prevent the build-up of condensation. And depending on the type and amount of insulation you use, you might need to think about introducing increased ventilation. Natural products such as sheep's wool, hemp and jute are therefore preferable and have the advantage of being easier to work with and have a lower embodied energy. Other products such as wood fibreboard can also be used. They have a higher thermal mass, preventing heat build-up in hot spells. Remember to take a whole house approach to energy saving and include easier energy saving measures first. Also remember, when introducing materials into a building, including insulation, think about the embodied energy of the materials themselves, how much energy it took in their manufacture, and their recyclability. Fortunately, many of the insulations compatible with traditional construction come from natural resources and have a relatively low embodied energy in comparison to the cheaper non-breathable insulants such as foam boards. You may also need listed building consent or planning permission if your home is listed or in a conservation area, as well as building regulation approval. So it's best to check before making any improvements. There will always be the need to provide effective ventilation to your home to provide good air quality and prevent carbon dioxide, carbon monoxide and moisture vapor buildup and reduce mold risk. There is a lot to consider when improving the energy efficiency of your home, particularly when you're introducing insulation. So consider an energy audit from a trained professional with experience of working with older buildings. They can help you choose what measures to adopt.